Okay, now that I've got your attention, guys. We are starting into proving triangle similarities. Okay, we used to, before we went on spring break, we had done a section on proving triangle congruency, where the two triangles are congruent. That means that all angles and all sides were congruent to each other. But now we're going to prove triangle similarity. Remember, in order for two triangles or for two polygons to be similar, the angles are the same, but the sides are proportional. In other words, it can be your triangle can shrink or it can grow and still have the same angles, but the sides are proportional. All right, and we've talked about proportionality. That's all we've really been talking about. So now we're going to go ahead and apply it to postulates. Remember, we had like the SAS, SSS, ASA postulates. We're going to have similar postulates for similarity. Okay, I'm going to show that to you here in just a bit. So let me go ahead and get my screen ready for that. Okay, so if you want to pause the video here so that you can take notes on the three different postulates we're going to be talking about. There's only three postulates as far as triangle similarity goes. It's the AA postulate, the SS postulate, and the SAS postulate. So hopefully you paused the video and took notes of that. Let's go ahead and first look at the AA postulate, and that's going to be angle-angle similarity. Okay, if you can prove that two triangles have the same angles, then you can 100% without a doubt state that they are similar triangles. Okay, so like it says right there, two corresponding angles are congruent, then the triangles are similar. Okay, remember, corresponding angles. This is going to be one of the sections where order matters tremendously. Order is going to matter quite a bit. Okay, so let's go ahead and take a look at some examples first of the angle-angle postulate for similarity. Okay, again, remember, if two corresponding angles are congruent, then the triangles are similar. Basically what that means that in the examples that we're going to work out right now, we only have to prove that two of the angles are congruent. Two corresponding angles are congruent. Once we've proven that, the postulate will hold to prove that the triangles are similar. Okay, so for example, in this first example, it says, determine if the examples below are similar by, and this is read as angle-angle similarity. Okay, the AA postulate, the angle-angle postulate. Okay, if yes, write a similarity statement. Okay, when we write our similarity statements, they're going to be very similar to how we used to write our congruency statements. When we'd say triangle ABC is congruent to triangle DEF or something like that. Okay, it's going to be the same way. And in fact, we're going to use the grid system to make sure that we organize our thoughts and are able to come up with our similarity statement. Okay, remember guys, order is going to matter, especially when you're looking for the second part of the similarity statement. And you'll see what I mean by that here in just a bit. Okay, so in this example, we have two triangles, okay, and we have to prove that two of the angles, there they are congruent or are equal to each other. Okay, and they have to be corresponding angles. So we look down here, we notice that we have a 75 and a 75. So far, we do have one pair of congruent angles that are congruent or that are equal to each other. So we have one of the A's so far. We need to find the second A. If you notice up here, we have 74 and we don't have a 74 here. We have a 31 here and we don't have a 31 here. That means we're going to either have to look to see if we can figure out this angle or this angle. And that's easy because we know that if we have two angles of the three angles, we can add them up, subtract them from 180, and we can find the third remaining angle. Okay, it just so happens that if you take 74 and you add that to 75, you get 149, I believe. 149. Yeah. 5 plus 4 is 9, 7 plus 7 is 14. Okay, and if you take that 149 and you subtract that from 180, you will get 31. Okay, so the measurement of this angle is 31 degrees. Okay, notice here, these two are the same. So we can stop there because we know that these two angles that are corresponding are equal, and these two angles that are corresponding are equal. So we fulfilled the two A's. Okay, so we're going to say that yes, these are similar. Okay, I'm just going to put yes and then the similar statement. Remember, it's just one wavy line. The congruent statement was the wavy line with the equal sign underneath it. Similarity statement is just the wavy line. Okay. The next part they're going to ask us is to give our congruency statement. I'm sorry, I'm already getting those confused. The similarity statement. I'm going to use the grid system to come up with my similarity statement. To me, that's just going to be the best way for me to figure it out. Okay, I'm going to go ahead and put this triangle first. The letters of this triangle, the vertices or the corners or the angles, whatever you want to call them, I'm going to put that at the top. And then the second triangle, the smaller triangle, I'm going to put that at the bottom. Okay, so remember, order doesn't matter. Not at all. Well, sorry, let me repeat that. When you're making a congruency statement, the order of the first triangle doesn't matter. It's the second triangle that it does matter. And that's why we're going to use the grid system. Okay, so I'm going to go ahead and just simply say ABC, just because that makes sense to me. All right, and now for the corresponding angles. Angle A was the 75-degree angle. Angle D is a 75-degree angle here, so angle D is going to go right underneath that. Okay, angle B was the 74. Now we know that this is going to be 74 also, because 75 plus 31 minus 180 is going to give us 74. And these two are going to be corresponding angles and congruent. So from B, the corresponding angle is going to be angle E. So you guys can see that. Okay. Make sure that this is okay. There we go. And last but not least, angle C. Of course, the 31 degrees is going to correspond to the smaller triangle that had the 31 degrees, so it's going to be F. Okay, so now with that, I can create my congruency statement. I'm sorry, my similarity statement. All right, I'm confusing myself again. Triangle A, B, C is similar to triangle D, E, F. Where did I get that from? I simply use the grid system that I have up here. Okay, ABC was the first one, and right underneath that is DEF. So that's going to be my answer. Okay. All right. If you have questions about that, make sure you come to the tutoring hour that you have on your scheduled A or B day for geometry. Okay. So there's a first example. Again, this is for angle-angle similarity. Okay, if you can prove that two angles on a triangle are congruent, are equal, then you've proven, you can stop there with the postulate and prove that the triangles are indeed similar. Let's take a look at another example for the AA postulate. Okay. In number 2 here, we don't have a lot to go off of. Okay, so we're going to remember what we've learned from earlier on in the year about triangles. Okay, remember, the task at hand here is we're trying to prove that two of the angles are congruent. Okay, we have to go based off of the information that's been given to us in the picture. Okay, we can't assume anything. There are things you can assume, but that's only based off of rules and postulates that we've learned earlier, and we're going to get into that right now. So first of all, angle V and angle Y, those two have one of those hash marks or those angle marks, whatever you want to call them. Okay, saying that those two are congruent angles. So we have one of the A's. We need to find the second A. Okay, now we don't have much to go off of, but the way this is drawn, we know that these two are what's called vertical angles. Remember, vertical angles are angles that are opposite of each other. And the rule is, if you have vertical angles, those angles are congruent. They are equal to each other. So we don't know what the degrees are here or the degrees are here, but we know they're equal to each other. So we can safely say, all right, angle X is congruent to angle X. Okay, going this way is angle X, going this way is angle X. Okay, it just happens to be the same exact angle, so they are congruent to each other. So we've found the second angle of the AA postulate. Okay, so now we can safely assume that these are similar. So are they similar? The answer is going to be yes. Okay, yes, they're similar. Now we have to come up with our similarity statement. So again, I'm going to use the grid system. That's going to help me out. Okay, so for the grid system, I'm going to go first with the first angle that we discovered were congruent, the one with just one of those angle markings. So I'm going to start with here. This triangle is going to go on the top, and all the angles on this triangle are going to go on the bottom. So the V is going to go here at the top first. Okay. And then the corresponding angle to that was Y. Okay. Next I'll go with X. Okay. X here. And X just happens to be the same angle on the smaller triangle. So XX, that makes sense. X is corresponds with X because it's the same angle. And then the last angle is the angle that doesn't have anything written on it. So on this triangle it's going to be W. This one, the angle that doesn't have anything written on it is angle Z. And now I have my congruency statement. Well, I have my grid. From the grid, I'm going to make my congruency statement. Okay, this is going to be the first triangle. This is going to be the second triangle. And I'm going to say triangle VXW, right? That's the one here on the top, is similar to triangle YXZ. YXZ. Okay, and that's my answer. My answer is yes, they are similar. And this is my similarity statement, because that's what they're asking in the question. Give me the similarity statement. Okay. All right. Hopefully that makes some sense to you. If not, rewind the video and take a look at it again, or come to the tutoring session video conference. Okay. All right. From there, let's go ahead and take a look at some examples for the SS postulate. Again, this is for similarity, and that's why they keep showing you this symbol right here. Okay, it's different from congruent. Congruency is different from similarity. Okay. Okay, so SSS stands for side, side, side similarity. Okay, according to this postulate, if all corresponding sides are proportional, then the triangles are similar. Okay, so all the sides have to be proportional, not just one, not just two. All three of the sides have to be proportional. You're probably asking yourself, what does that mean? Okay, we've talked about this before, but I am going to show you, and I'm going to show you an easier way to test this out in your calculator. Okay. All right. So hopefully you wrote that down in your notes. First example says here, determine if the examples below are similar by SSS. If yes, write the similarity statement. Okay. This is going to be easy, guys. I promise you. Check this out. We have two triangles. They appear to be two isosceles triangles. What's an isosceles triangle? A triangle where all the sides are different lengths. Okay, so check this out. I'm going to go ahead and first write my my grid here. Okay, I'm going to assume that it is similar, but I have to prove it to myself before I can officially make that statement. So I'm going to try my best to first come up with a grid that might work, and that'll help me get to my answer. Okay. Now remember, in how should I say this? In an isosceles triangle, we have an order of the sides. Okay, we start with the smallest side and go to the biggest side. All right. So for example, this first triangle, it's going to be the triangle that's going to go up here in my grid. All right. I'm going to start with the smallest side first. This side is length 3. Okay, and length 3 is side PQ. Okay, so I'll start with PQ here. PQ. Okay, now I'm going to see if I can determine the corresponding side that's over here. Okay, the smallest side on this triangle between 10, 8, and 6, of course, is going to be 6. That's the smallest side. So this side corresponds to this side. But you have to make sure, because now that we're using two letters, we have to make sure that we're going from the P to the Q. Okay, looks like it's going from P, which is connected to the side that's the next largest side, and it goes up to Q, which is connected to the biggest side. So I'm going to do the same thing here. I'm pretty sure it's going to be ST, but I want to make sure that it's following that same pattern. S is connected to the side that's in the middle, or the next biggest side from 6, and it goes up to T, which is connected to the bigger side. So the correct statement is going to be ST underneath right here. ST. Okay. Again, I don't know if they're similar. I haven't proven to myself if all the sides are proportional to each other. Okay. I'm just trying to see like if I can test something out here. Okay. Now, if you notice PQ, ST, you're pretty much done because all that's left is the one letter that you haven't touched. In the smaller triangle, the only letter we haven't touched is R. And in the bigger triangle, the only letter we haven't touched is U. So I'm going to go ahead and put U here. Okay. If these are proportional using side similarity postulate, then this is going to help me write my similarity statement. But I still need to prove that all the sides are proportional to each other. Okay. Basically what that means is that I'm going to go ahead and set up 3 fractions, and I want to make sure that they're all equal to each other. Okay. The way I'm going to do that is the top part of the fractions, the numerators, are going to represent the smaller triangle, and the bottom part of the fraction is going to represent the bigger triangle. Okay. How am I going to list them? I'm going to list them from the smallest side to the largest side. So watch how I do that. Okay. Right here, of course, the smallest side is going to be 3. The next biggest side is going to be 4. And the biggest side is going to be 5. Okay. I'm going to follow that same pattern for the denominator. The denominator is going to be all the numbers in the bigger triangle. All right. Starting, of course, with the smallest number. Between 6, 8, and 10, 6 is the smallest number. The next bigger number is going to be 8. And the biggest number of the 3 is going to be 10. Okay. What I'm going to do is I'm going to use the calculator, the TI Nspire, to see if this fraction is equal to this fraction is equal to this fraction. If they're all equal to each other, then we do have proportionality, which proves that these two triangles are similar using the SSS postulate. Okay, the side postulate. So watch how easy this is, okay? Now, don't get this confused with nsolve. We're not using nsolve. Why? Because we don't have a variable. We don't have an x. We don't have something that we're looking for. We just want to know if these fractions are equal to each other. Now, unfortunately, the TI Nspire can only work with one equal sign at a time, so I can't put in the whole thing at once. I'm going to have to put in this one first, and then I'm going to have to put in this one second. And you'll see how I do that right now. So let's go ahead and go over to our calculator. And I'm going to go to Add Calculator. And I'm simply just going to put in my first fraction. Okay, my first two fractions, which was 3 over 6 is equal to 4 over 8. So I'm going to go Control division sign. 3 over 6 is equal to 4 over 8. Oops. Control division 4 over 8. Okay. If this is true, when I hit enter, it's going to say on this part over here, it's going to say true. Okay. So far, we've proven that 2 of the sides are proportional to each other, but we still have to prove the last one. Again, I can't put in all 3 equal signs, so I have to do them one at a time. Okay. So now we have to prove is 3/6 equal to 5/10. All right. The way we do that, hit up, up. Once you see that highlighted, hit enter. That's going to copy and paste it for you. Click back, and now you can delete the 4/8 and put in the 5/10. Okay, 5/10. So you're going to have to do it twice for this postulate. Okay, hit enter. If it's a second true statement, then you have proven that 3/6 is equal to 4/8 is equal to 5/10. And that means that this triangle is proportional, which you've proven that they do meet the requirements for the side similarity postulate. Okay, so now that we have our proof, I'm going to go ahead and write my statement. Okay, I'm going to use this grid to write out my entire statement. And I'm going to say that triangle PQR, right? That's the first triangle. PQR is similar to triangle, oops, I wrote A, to triangle STU. STU. Okay, and that's my answer. My answer is yes, and that's the similarity statement. Okay, and again, this is going to come in handy. Please, please, please get in the habit of drawing out this grid. Okay. Okay, so there's the first example for the side. We'll go ahead and try it again in this example. Again, we're determining if the example below, if this example is proportional using, or I'm sorry, similar using the side postulate. Okay, side postulate. So again, we're going to do the same thing. We're going to have to determine if the sides are proportional to each other. Okay, I'm going to go ahead and start with proving it first, and then we'll go ahead and do the grid, and then we'll do the statement. Okay, so again, this is going to come really easy. All you have to do, make 3 fractions. Okay, the top part of the fractions, the numerators, are going to be one triangle. So I'm going to start with the bigger triangle. The denominators of the fraction is going to be the second triangle, which will be the smaller triangle. Okay, you can do it either way. You can start here and go back this way, but since I don't know, just reading left to right is kind of a natural thing for us, you can do that. If you do it the other way, it's not wrong. You just have to make sure you stay consistent. Okay, so bigger triangle. Let's go ahead and order the sides from smallest to biggest. Okay, the smallest side here is going to be 30. The one in the middle is going to be 32. And the largest side is going to be 35. Okay, so that's the big triangle. Now the smaller triangle is going to go down here. Same thing, order them from smallest to greatest. The smallest side here is going to be 24. The next side up is going to be 25. And the largest side is going to be 28. Okay, I'm going to go ahead and plug this into the calculator. If they're all equal to each other, then we can say, okay, we can say that they're all proportional and that this is a similar triangle based off of the side postulate. So let's go ahead and do that. Go to my calculator here. I'm going to clear this out. Okay. Get my fraction up here. The first fraction is going to be 30 over 24. Control division sign. 32 over 25. 32 over 25. Okay. Again, I can only do one at a time. I can't do all 3 fractions at once. So look right here. We ended up getting a false statement. We can stop at this point. We cannot prove that these 2 triangles are similar using the SSS postulate. Okay, if these 2 are not equal to each other, that means that the sides are not proportional to each other. Okay, so this is going to be no. Okay, they're not similar. No to similarity. And that's why I didn't want to draw the grid just yet. Okay, if it was true, then we could have drawn the grid and then gone from there. But since we know for sure that these are not equal, then we can stop there. Okay. All right. From there, again, that's side. Okay. Side similarity. From there, we'll go ahead and go on to the last postulate, which is side-angle-side similarity, or the side-angle-side postulate. There we go. Okay, so according to this, it says, if two corresponding sides are proportional and the included angles are congruent, then the triangles are similar. Okay, now the keyword there is included. In other words, the angle, notice how the angle's in the middle of the two sides. The angle has to be included. It has to be in between the two sides that you're checking for proportionality. Okay, and you'll see that here when we work out some of the examples. So it says here, determine if the examples below are similar by SAS postulate. If yes, write the similarity statement. Okay, so this one, we're going to be checking angles and checking sides. Okay, the first one we were just checking two angles. The second one we were checking three sides. Here we have to check two sides and an angle. And again, that angle has to be included. What that means, guys, is you see how there's this side here and this side here? In between these two sides lives this angle. This is the included angle. Okay, here's the side, here's the other side, here's the angle. This is included between these two sides, side, angle, side, side, angle, side. We have to prove that the angles are congruent and the sides are proportional. Okay, so it's kind of like taking the first two postulates and mixing them together into the last postulate. Okay, so angles first. Let's do the angle first. Angle, angle. Okay, we know that these two are congruent to each other. They're the same angle. We don't know what the angle is, but with the markings that's been given to us, we can say, okay, for sure, angle K and angle N are similar to each other. They're congruent to each other, I'm sorry. So, so far we have the A. Okay, now we need to check the sides. And the sides have to be the ones that include K, the ones that include N. So it has to be these sides. They're kind of giving you a hint here because the only ones that are labeled are the sides that are on the opposite sides of this angle. Okay, so same thing. Before we were checking side, 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 we were using 3 fractions. This one's a little bit easier. We only have to do 2 fractions now. Okay, so let's go ahead and set that up. We'll set it up like this. Just want to make sure you guys can see it on the screen there. Okay, so instead of 3 fractions, we have 2 fractions. Okay, the numerator is going to be the numbers here. The denominator is going to be the numbers here. Okay, do the same thing. Go in order from least to smallest. All right, so starting with the bigger triangle at the top, what's the smallest number of the two? 8. The largest number is 20. Okay, going to the second triangle, the smaller triangle, which is going to be the denominator numbers, go in order again from smallest to greatest. Smallest number here is 6. And the biggest number here is going to be 15. Okay, if these 2 fractions are equal to each other, then we can say that this is these triangles are similar. So let's go ahead and check that. I'm going to just copy and paste this and then just redo the numbers here. So the first was 8 over 6. 8 over 6. The second one is 20 over 15. Remember, you're not using NSolve. You're just using a regular calculator. Okay, you're asking the calculator if this is a true or a false statement. Okay, we're hoping for true. So let's hit enter. True. Okay, good. That means that the sides are proportional, and we already know the angles are congruent. So these 2 triangles are in fact similar. Okay, so to answer the question, yes, they are similar. But now we need to give our congruence, our similarity statement. Okay, I'm going to use the grid again. Okay, we know for sure that the angles K and N, we know for sure that those 2 angles are corresponding, they're congruent to each other. So the top part's going to be the bigger triangle, the bottom part's going to be the smaller triangle. So I'm going to go and put K here, just in the middle, because that's the A part. Okay, see how the A part's in the middle? You don't have to do it like that. All the sides will correspond to each other. You just have to make sure that you stay consistent. Then N's going to go right here. I could put the K and the N here at the beginning as long as they're on top of each other. It doesn't matter where they show up. I'm just doing that because the angle's kind of like in the middle. Okay, hopefully you guys can see that. So k is corresponding to n. K corresponds to n. Okay. So from k, I'm going to go down the side of the triangle that's the smallest side. So from k to j. So I'm going to go ahead and put j on the left side of k right here. Okay. Follow that same pattern. All right. From the one angle that we have, am I going to go down this way or this way? I'm going to go down the smallest side first. So from n to m. So I'm going to put m. M is the one that corresponds with j. Okay. And then the last letter is just the letter that's left over. You don't have to think about it. Okay. J, K, L is the last letter. We haven't touched that letter. And the last letter that we haven't touched here is P, and that's going to be the corresponding side, or the corresponding angle to L. Okay. So now we have our grid. From here, I can write my congruency statement. Okay. My congruency statement is going to look like, where can I write it? I'll write it right here. I'm going to say triangle J, K, L is similar, I keep wanting to write an A, is similar to triangle MNP. MNP. Sorry, I'm having to write small there, but there's my answer. Okay. The first part of my answer is yes, they are similar. The second part of my answer is the congruency statement. If you guys can see that. MNP. Triangle JKL is similar to triangle MNP. Okay. All right. Last one, last example we're going to take a look at here. Again, we're talking about side angle side for this last example. And it's going to be this example here. Okay. Again, our goal is that we have to prove that two of the sides are proportional to each other, and one of the angles, specifically the included angle, is congruent to each other. We can prove that. We can say without a doubt that these two triangles are similar to each other. Okay, so let's go ahead and work with the angles first. All right, notice the way this is drawn, and actually this is a good example. If you notice, the smaller triangle is kind of overlaying the bigger triangle. Okay, it's kind of like on the inside. The only thing that we can assume from this, because remember I always said don't assume unless you have markings. You have to go based off the markings. Don't assume anything from the drawing itself other than the markings and the values that's been given to us. The one thing that you can assume, kind of like the vertical angles that we saw over here, because based on the way it was drawn, okay, the one thing that we can assume from this drawing is that this angle for the smaller triangle is congruent to the same angle of the bigger triangle. In other words, A. Angle A is going to be similar or congruent to both triangles, because the first triangle is triangle ADE and the second triangle is ABC. Okay, they both share angle A. So we can say, all right, for sure, we know that that angle is congruent for both triangles. So we have the A part. Okay, now we have to determine the sides. And remember, the angle has to be the angle between the two sides that we're going to check for proportionality. It has to be what's called the included angle. Okay, this is the included angle from this side and this side. It's in the middle of the two sides. All right, so we've proven the A part. Now we need to prove the S parts. So again, I'm going to do basically I'll do it right here, the fractions. Okay, let me erase this here so that it doesn't confuse us. All right, so let's go ahead. I'm going to reserve the top part of the fraction for the smaller triangle and the bottom part for the bigger triangle. Okay, so let's go ahead and order the sides from least to greatest for the top part of the triangle. I'm sorry, the smaller triangle, which is the numerator. So let's look at the smaller triangle. Okay, we only have two sides, side 15 and side 12. Which is the smallest of the two? It's going to be 12. Okay, and then the largest of the two is going to be 15. That's going to go over here, right? Now the denominator is going to be for the bigger triangle. Right? The bigger triangle, this side is 25, and this side is 21, which is the smaller of the two. Since you're going from least to greatest, it's going to be 21 first, and then the larger side, of course, is 25. Okay, so we have to see if this is a true statement. If this is true, then those sides are proportional, and we can say without a doubt using the SAS postulate that these two triangles are similar. So let's go ahead and check that in our calculator. Again, I'm going to just copy and paste this one. We'll put in our first fraction of 12 over 21. 12 over 21. Second one is 15 over 25. 15 over 25. Okay. It's false. So we're going to stop there, and we're going to say these two triangles using the SAS postulate are not similar. Okay, so no, they are not similar. That's my answer here. I'm not even going to write a similar statement because I don't have to. They're not similar, so I don't have to write a statement. Okay, so that is 6 examples, 2 of each on triangle similarities. Okay, remember the 3 postulates are angle-angle, side-side-side, side-angle-side. Okay, some of your questions on your assignment this week are going to ask you if these triangles are similar using the 3 different postulates, and you just simply say yes or no. It'll ask you first, are these similar using angle-angle? And you say yes or no. Are these similar using side-side-side? Yes or no. Are these similar using SAS? Yes or no. Okay. Then the second half of your assignment, or the last few questions, the last 4 questions, are going to ask you to write out the similar statements. Okay. Notice here we had 1, 2, 3, 4 of these were similar. Okay, these 2 were not. So if they are similar, write this statement. How are you going to write this statement? Use the grid. I promise you, if you use the grid, it's going to help you out. Notice I used in those 4 problems, I used the grid 4 times to get these statements. Okay, so try your best. If you have questions during school hours, if it's outside of our conference time, send me an email. I can usually get back to you if I'm not in the middle of a conference call. But the best way is to come to the video conference. Okay, that is, some students are asking if I'm offering tutoring hours. That is the tutoring hour. Okay, come to the conference so that you can get tutored, you can ask questions, I can help you out. I've had several students already come in asking for questions, and we're able to do the document camera just like I have it here in the lectures, and they can see everything and it works out just fine. Okay, so make sure you come to video conference if you need it. If you need it, you don't have to, but if you need it, please come. Okay. All right. With that being said and done, good luck, guys. Wrestling shirt of the day. AJ Styles, the phenomenal one. Too sweet me, baby. Woo! I'll see you guys next time. Bye.